In this video, I'll show you how to use this fading feature. And fading allows you to destroy or exclude from simulation your objects or fragments. There are three ways to initiate this fading. And right now I will show you this three ways and explain when you should use them. So first one is on demolition, and it allows you to fade your fragments. So after they will be simulated for some time, you will be able to get rid of them, and in this way you won't keep in your scene a lot of fragments everywhere. So here you can see I demolished my object, I got these fragments, and now I'm fading all these fragments, and that's it. I don't have any of these game objects anymore in scene. Next way to initiate fading is on activation, and it works for inactive or kinematic objects. In this case, it works for actual object, which is not going to be demolished. If I will initialize it, nothing will happen because right now this object is deactivated since it's inactive. In the same way it works for kinematic. And there are a lot of ways to activate. You can see how to activate objects in activation tutorial. Right now I will just click this activate button. Okay, now this object was activated. And now you can see it says here fading in progress, but before it said that object about to fade. Let me show you again. I click activate, object about to fade, and after some time fading in progress, and that's it. Another way to fade your object is by using this by offset property. So it measures in units and it allows you to fade object if it will be moved too far from its original position, which is positioned when this object initialized. So in this case I'm using 4 units and I initialize my object. See, for now it's not too far from its original position here, but if I will move it too far from its position, I can see it's starting to fade. Also, you can use the same for fragments. Right now I'm using 10 units, and this time I want to demolish my object. And sometimes, let's say you have very thin collider, so you may have some object which will slip through this collider and will start to fall down infinitely. You can see. So here you can see there are a bunch of fragments here. They slipped through this collider, and now they will fall down infinitely. But since I have here by set to 10 on the original object, and as you can see, they moved too far from their original position. They were created here when object was demolished. This is the place where this fragment were created. And as you can see, there's just obviously more than 10 units here. And these objects already start to fade. Here you can see it says object about to fade. We can check them. I will select them. You can see. Okay, that's it. There's no any objects now here. In this way, you can demolish your object and not to worry about if there will be some fragments that will slip through colliders and will start to fall down infinitely. Just use this by offset fading and all these fragments will be destroyed over time. There are 7 fading types here. I will show you each fading type. First one is destroy, and it basically simply destroy all fragments after their lifetime. This is the fastest and the quickest fading type. Next one is move down. It moves all your fragments under the ground based on their size, and then they will be destroyed. Next one is scale down. Instead of moving objects, it will scale them to the 0 scale, and after that they will be destroyed as well. Next is fall down. It looks like move down, but this time they move down by the gravity, and then they will be again destroyed. Next one is set kinematic. After a lifetime period, your fragments or objects will turn into kinematic object here. You can see, even though it says here original simulation type, In fact, they turn into kinematic. They're still part of the simulation scene. Other objects can interact with them, but they won't be moved because now they're kinematic. They can be moved if necessary, and they will push other dynamic objects, but nothing can affect them. Next type is set static. It looks like set kinematic, but this time fragments loses their rigid body component. Only collider stays. It works like kinematic, but other dynamic objects still can interact with this object, can collide with them, but they won't be affected. And they can be moved because if you will move them, they kind of will affect dynamic object, but the simulation won't be accurate. If you want to move objects and affect in the right way, you should use kinematic simulation type. And the last one is sim exclude. It destroy all components, rigid body and mesh collider. It only leave this mesh filter and mesh render. And as you expect, other dynamic objects won't affect and won't collide with this mesh because now they are not part of simulation scene. When you start to fade your object, there are two periods of time. First one is lifetime, when object is not faded yet. This is the moment when you see this message that object is about to start to fade. And then there's actual fading time. It works only for move down, scale down, and fall down fading types, because this fade types require some period while they will affect an object. So this is the time which you can define how quickly object will scale down or move down, or when it will be destroyed, when it will start to fall down. For set kinematic, set static, and sim exclude, you don't need this fade type because they works instantly. So here I have three objects here, and on the left object I set fade time to 2 seconds. So for the middle it's 5 seconds, and for the right one it's 10 seconds. And take a look how it works. Here you can see that fragments on the left side will fade very quickly, 2 seconds. For this one it takes 5 seconds, and on the right side it takes 10 seconds to scale down. So this is actual fading time. It's not the time when objects stay in scene. So I can increase my lifetime 10 seconds. You can see that it says here object about to fade, but all objects still in scene. So right now this is their lifetime. But when 10 seconds will pass, now you can see that again they start to fade. And most of the time takes this fragment because they need 10 seconds to fade. And now I will show you how lifetime works. So in this case, for all my 4 objects, I have 1 second fading time, so they will fade pretty quickly, but you can see the difference on when they will start to fade. For our first object, lifetime is set to 2 seconds, second is 10 seconds. For the third one, I'm using 2 seconds, but with 10 seconds variation, and the last one is 10 seconds, and then 10 seconds variation. Variation adds random value, so for this one it will start after 2 seconds, and all fragments will start to fade after 2 seconds of life. In this case, they will wait for 10 seconds, and then all of them will start to fade after 10 seconds. And for this one, they will start to fade after 2 seconds life, but every fragment will start in random range from 2 seconds to 12 seconds. For this one, all of fragments will wait for 10 seconds, and then they will start to fade in a period from 10 seconds to 20 seconds. Again, you can see on the left, they start pretty quickly, all of them at the one moment. As you can see, one fragment by one, they start to fade. I'll show you again. As you can see, this rock all fragments start after 2 seconds. So these 2 fragments, they all basically fade instantly. All the fragments start to fade in the same moment because there is no any variation for them. This one start after 2 seconds and this one start after 10 seconds, but all of them start instantly. And if you want to add some variation, Then you can use this variation spinner. So one of the fragment will start to fade while other will stay in scene. So they will kind of fade in a smooth way. This is how live property works. Also, there are two live types here. The first one is by live type, which I showed you in previous example, but you also can use this by simulation and live type. So in this case, you can see I'm using the same live time period for both objects. Also, fading itself will take 1 second, so everything will happen pretty quickly. But for this one, when fragments will be created, they will have 2 seconds in scene. After that time, they will start to fade. So they will crumble down and they will start to fade while they will crumble down. But for this one, I set here by simulation and live type. And it means that first all these fragments have come to rest. So they should stop simulating. And only after that time, this lifetime will start to count. You see fragments on the left, they already faded. But these fragments, they still crumbling down, and only after they will stop, only after that they start to fade. So if you want to wait until your fragments will come to rest and then start to fade, you can use this by simulation and live type. Next properties here is filters, and this property allows you to keep some of your objects in scene if they're big enough. So if you don't want to fade very big objects, you can use these filters. When it's 0, it means it's disabled. But for this second object, I use 0.5 units. So it means that only fragments with size less than 0.5 units will be faded, which means small object will be faded, while bigger objects will stay in scene as dynamic objects. And for this one, I used value 0.9. It means that only very big fragments will stay in scene. Now let's check how it works. So you can see on the left side, all fragments faded. And here only very small fragments faded, while on the right side, most all fragments faded, but very big fragments stayed in scene. As you can see, they're dynamic. You can continue simulating them. And here you can see their size here. This one is more than 1 unit. So as you can see, only fragments with size bigger than this value stayed in scene, while other fragments were faded. And in this case, I used value 0.5, so I have more fragments in scene. Also, the same way it works for connected clusters. Here are my two clusters. Here you can see for this one I'm using value 0, which means that all fragments and subclusters will be faded. But for this one I'm using value 1.2 units. And if you will see cluster demolition properties here, you can see in my demolition distance is 100, means that all clusters will be demolished completely. But shards area is 0, so I won't get any shards, separate fragments. I will create only 25 to 30 subclusters. And here you can see on the left side all subclusters also fading down, while on the right side only very big subclusters stayed in scene. And last property here is filter by shards, and this property works only for connected clusters. So again, for this left object, I have it at 0, which means it's disabled. For this on the right side, I have it at 5, and it means that when I will demolish this cluster to lesser subclusters, all subclusters with 5 or less shards will be faded, while subclusters with 6 or more shards will stay in scene as dynamic objects. Here you can see all subclusters start to fade, and here only small subclusters faded, while this big one stayed in scene because they have, here you can see in info section, All of them have 6 or more subclusters. One has 8 shards. So in this way, using these shard filters, you can keep in your scene subclusters with big amount of shards. Depends on how many shards you want to keep in scene. This is how we can use this filter shard property.